Okay, guys, so I'm starting here with a new topic, that is the chemical kinetics. So, chemical kinetics, that is the word kinetics itself means that is what? That is the rate. Okay, and rate we know, rate is something with respect to time. Okay, that's something with respect to time is called rate. And here we are dealing with the chemicals. It basically means that reactions. Okay, so we are dealing with the rate of what? Rate of the reactions. Okay, means that particular reaction is taking how much time to complete in a particular time. For example, we have this A plus B and it gives this product P. Okay, so we know by thermodynamics, we know thermodynamically, we know that it only tells about the feasibility of the reaction, about feasibility of the reaction. It tells about, sorry, here, okay, it tells about the feasibility of the reaction. That is, feasibility means that whether this reaction is going to happen or not. If delta G is less than 0, okay, it means that delta G is negative, which means that this reaction is spontaneous. That is, this reaction will ultimately going to start itself. Okay, this is this much knowledge we gained about the thermodynamics, that it tells whether this reaction is going to happen or not. But the major problem is that we can't identify the rate of the reaction. That means that in how much time this reaction is going to happen, we couldn't find out. So, for that, we study the chemical kinetics, in which we are broadly studying about the rate of this reaction, that in how much time this particular reaction is going to happen. So first of all, we are going to see about the perspective of this rate of the reaction, that how we are going to calculate it. So graphically we are going to see here that suppose this is a reaction A plus B and it gives P product. So what happens during the starting of this reaction, this particular reactant A is getting reduced, this B is getting reduced, then only this product P is getting formed. Okay, this much we know. So what happens, let's suppose draw the graph between, here we are going to take the concentration, है ना, because we are going to dealing with the rate, and rate is something with respect to time. So here what is changing, here the concentration is changing with respect to time. So in considering the rate, we are going to see the rate, that is in which respect, concentration. Okay, we are going to see concentration with respect to time is changing, that is the rate. Okay, so here we are taking the concentration and here we are going to take the time. Suppose this A is a reactant. Suppose in this we are going to simply see A is converting into the product P. Only single entity reactant species we have taken, not the two one. Okay. So if this is a graph for A is converting into product P. So here the reactant is getting, concentration is getting less and the product concentration is getting more. So we are going to plot, suppose here it is for reactant, so its concentration is getting decreased, suppose like this. And here in the next graph, this product concentration is getting more. So suppose it is getting more or increasing. But we actually this is supposing graph. Okay, it is not the exact graph. We cannot say that this is the exact graph, because decreasing can like this it will decrease, okay, like this it will decrease. So we are not exactly knowing the nature of the graph. Okay, But and in this case also, if it is increasing, so it might say like it will increase like this, or it will increase. So we are not knowing the nature, it is just the hypothetical graphs we are drawing for this. Okay, so rate is this, and we know that now the question is how we are going to denote the rate of the reaction. Okay, suppose this is a graph. Okay, and it is like this is distance, this is denoting the distance, and this is denoting the time. Okay, suppose the function is written dt cube, and we have to time find out the time in 10 seconds. So how we are going to find out? We know that this is a slope, and slope is generally represented as differentiation dy by dx. So what we are going to do, we are going to find out the slope, which is equals to dy by dx. That will be equals to, here this is given in differentiation form, so we are going to calculate the differentiation of this, that is d by dt. That will give you dt cube by dt. That is because we are doing in respect to time, so 2 dt square with dt, which is equals to 2, and here we know that time is 10 seconds, so here we are going to take 10 seconds. 10 into, sorry, it will be 3t square, so 10 into 10, that will give you 300. Okay, so this is your answer. So how we calculated? We calculated by the differentiation method. So we are going to calculate the same way, we are going to calculate the rate by differentiation method. Okay, तो differentiation method से ही हम क्या calculate करेंगे? We are going to calculate the rate of the reaction. So let's see, let's come to another page. Okay, now we are going to calculate we are seeing how we are denoting the rate of the reaction. So we know that this is a reaction A plus B, and it gives product, suppose C plus D is the product. Okay, so rate of reaction, we know that it is denoted as differentiation, that is differentiation of concentration of A upon K time, because with respect to time we are considering the rate, that is the concentration of A is changing with respect to time. Then this is in starting, we know that it is the rate of this and this every species rate is not equal, so it is not equal. B, then rate of concentration of C with respect to time, rate of concentration of D with respect to time. Is it? Then these rates are not equal. Is it? Okay. These rates are not equal. Okay. Then how we are going to make it equal? Okay, we know that suppose this is 2, this is 1, okay, this is 3, and this is 5. These are stoichiometric coefficients. These will only become equal when we are going to divide these particular coefficients with the denominator. Okay, suppose this can be written as 1 by 2 differentiation of A by dt equals to 1. It is this coefficient is 1, so we are going to divide it only with 1. Okay, then it will be equals to this coefficient is 3, so we are going to take in the denominator 3 itself. Okay, dc by dt, that is 1 by 5 dd by dt. Okay, now this is the rate of reaction. Now this is called rate of the reaction, and we know important point here is that 1 by 2, if I am going to write this, then this is what this is denoting, that the concentration of A, that is a reactant, is with respect to time, but here this coefficient is also written in denominator, so it is actually denoting the rate of reaction. Okay, This is the rate of reaction. Okay, but if I am going to take this, like if I am going to take this species as dA by dt. Okay, so this is only telling the change in concentration of A with respect to time. So this is not the, this is only the rate of, and we know most important thing, that is reactant are denoted by the negative sign in between. These are the negative signs, and the product are with the plus sign in between. They are the equal sign. Equal हमने करा by dividing these coefficients with the denominator. इज इट, इससे ये सारे रिएक्टेंट के रेट्स जो थे, प्रोडक्ट के रिएक्टेंट के जो रेट रिएक्शंस था वो इक्वल हो गया बाय डिवाइडिंग दीज विद द कोफिशिएंट. इसका एक अलग कॉन्सेप्ट है कि हमने कोफिशिएंट्स को डिनोमिनेटर से क्यों डिवाइड किया, दैट वी आर गोइंग टू सी इन अनदर video. But here you have to remember that the coefficient given in the reaction will be divided while writing the rate of the reaction. And here the reactant species, the rate of the reactant species will be denoted by the negative sign, and the rate of the product species will be denoted by the positive sign, and in between the equal signs are denoting. Okay, so if we are writing with the coefficients the concentration of reactant, then it will be the rate of the reaction. If we are writing without the without these coefficients, only the rate, then it is giving about the rate of the decomposition of A. That is, the rate of decomposition means how much the concentration of a reactant with respect to time has been finished. Okay, has been decomposes, because it is a reactant we have taken in the reaction, we have taken this as reactant. So this is rate of decomposition of A. Okay, now another thing we are going to see or deal here about the molecularity and the order of reaction. Okay, so molecularity and order of the reaction. Okay, molecularity is nothing but it is simply, it is equals to the sum of coefficients of reactants of the reaction. Okay, suppose this is a reaction, A plus B gives C plus D, and these are the coefficients 2. Okay, so molecularity means sum of the coefficients of reactants of the reaction. यानी कि जो हम रिएक्शन हमारा है उस रिएक्शन में जो भी रिएक्टेंट है, दिस वन इज रिएक्टेंट, दिस वन इज रिएक्टेंट, उसके जो भी कोफिशिएंट्स हैं, स्टाइकोमेट्रिक कोफिशिएंट्स होते हैं, जो भी स्टाइकोमेट्रिक कोफिशिएंट्स हैं उसका सम मोलिकुलरिटी होती है, दैट इज 2 + 3 is equals to 5. This is the molecularity. For example, N2 plus 3H2 gives 2 molecules of NH3. This is the Haber's process. Okay, so molecularity क्या होगा इस केस में, molecularity will be equals to, only we are going to see the reactant, only we are going to see reactants coefficients, not the product one. इस product one के हमको coefficients नहीं देखने हैं, हमको सिर्फ reactants के coefficients को सम करना है, वो हमारा molecularity. तो इस केस में molecularity क्या हो जाएगा, 3 + 1, 3 + 1, that will give you 4. This is the molecularity. Okay, in another video we are going to study about the order of the reaction. What is order, how we are going to calculate the order. Okay, thank you friends for watching my video. Please subscribe for more videos.